Hey, it's Dr. Annawalt. I'm here to walk you guys through some review. You might remember last time in class we were talking about how to use input and output. We were also getting some practice doing calculations, and we ran out of time to do an example together at the end of class. So let's do that together now. I'm going to share my screen so that you know what we're working on. So at the end of the notes from Friday, it had a practice problem about writing code on paper. And you might wonder, why are we doing that? Why aren't we using IntelliJ to write this example? And it's because in the exam environment, you'll be writing your solutions on paper. And so to provide you with some experience about what that feels like and looks like, we're doing some intentional examples in class so that you feel prepared when you get to that first exam. So let's look at this question. It says on paper, write a program to read in the length and width of a rectangle from standard input. Then calculate the area and perimeter of the rectangle. Then it reminds us about the formulas for area and perimeter. That's useful in case you don't recall those. And certainly, I don't expect that you have any particular experience or remembrance of geometric formulas you might have encountered in the past. If it's not something that we've seen before in class, I wouldn't expect you to know about it on an exam. Finally, it says display the result with 2 decimal places using the labels area and perimeter. And then it provides us with the kind of shell of the program. On an exam environment, I'll always give you the line that says public class main and the line that says public static void main string args, just acknowledging that those don't even come up in everybody's editor anymore. And certainly those aren't things that you need to memorize. The editor window fills those in for you no matter what. So as we're getting started here, let's think about the variables that we would need for this program. It's always a good idea to think about what variables, what data storage am I going to need? What data types should those variables have? Will those be entered by the user or things that are calculated by my program? And what would be a good identifier for each of those values? So pause the video here for a few minutes and brainstorm just with yourself on a piece of paper. Think about the different variables you might need in this program and those different characteristics that each variable would have. Once you have your ideas on paper, then unpause the video and you can come back and check your answers. So this program is going to have 4 different variables in it. It's going to include the length of the rectangle and also the width of the rectangle, and then the area and the perimeter. So this will be our 4 variables in our program, and these identifiers would be fantastic and descriptive for those different values. By default, Word capitalized them all. In general, we'd use lowercase identifiers for all of those different variables, but certainly it wouldn't be wrong to have capital letters. That would compile and work just fine. Next, we need to think about what kind of data type. And so I'm looking through here for clues, things that would tell me what data type the length and width, area, and perimeter should be. And when I get to the bottom, it tells me to display them using 2 decimal places. And so that's a tip off to me that those should be decimal values, that they have the potential to not be whole numbers. And so I would pick the data type double for all 4 of these variables in my program. And finally, we were thinking about which values would be entered by the user and which ones would be calculated in the program. And in the description, it tells us that the length and width should be read from standard input. That means those are going to be entered by the user. And it provides us a formula for the area and perimeter. That's a good indication that those are things that you need to calculate in your program. Super. So at this point, we have a good idea about those variables that we'll need in our program, and we're ready to start writing our code. I'm going to type it in our window here. Of course, it would be ideal for you to write it on a piece of paper rather than type it, just so you get that real exam experience. Again, pause the video, and while you're gone, think about how you would declare these 4 different variables in your program. Once you have an idea, then come back and you can check your work. So we're declaring these 4 variables in our program that would go in here in the main. And we want to declare a double for the length, a double for the width, a double for the area, and finally a double for the perimeter. Super. The next steps in our program are going to be to make our calculations the next step in our program is going to be to read the data from standard input. So we have to think to ourselves, what would we need to add in our program to set ourselves up for that and to successfully read data values from standard input? Again, brainstorm to yourself, write down your ideas about how to solve that portion of the problem, and then come back and unpause the video to check your answer. So one thing we need to do if we're going to use standard input is to declare our scanner. So I'm going to set that up in my program. And I want to set it up to read from standard input. So I'm going to put system.in in the parentheses there. And then I'm remembering that I need to include a library in order to get access to the scanner. I'm going to import that library up here at the top. And that's the java.util library. Next, in order to read standard input, I need to tell the user that I'm expecting them to enter some data. And in this example, it doesn't give a specified prompt, anything in particular that we have to use to tell the user to enter the length and width. So I'm just going to pick something that makes sense to me. I'm going to say system.out.println, so I print that prompt to the screen. And I'm going to keep it simple and say enter length and width. Once I have that prompt in there, then I can read data and store it in my length and width variables. That would look like this, where I say length gets standard in dot next double, and then width gets standard in dot next double. Awesome. Words being super helpful here and capitalizing my variables. But of course, that wouldn't be accurate. They shouldn't be capitalized in my Java program since I used lowercase in the declaration. We just have a little bit of code left for our solution. We need to be able to make our calculations for the area and perimeter, and then finally display the results with 2 decimal places. Brainstorm how you would complete the program, pause the video, and then come back and we'll go over the results together. So our next step is making the calculation, and we want to calculate the area. That is the length times the width. And so I'm using the Java syntax for multiplication. That's the asterisk symbol. And then to calculate the perimeter, that's the length times 2 plus the width times 2. And I might think through, do I need to have extra parentheses in this expression to force it to do the multiplication before the addition? And I don't, because the multiplication has higher precedence. So it's going to do the length times 2 first, then do the width times 2, and then add together the 2 sub-results. If you weren't sure, you could always add some extra parentheses in there to make sure that the expressions or the operations were executed in a particular order. Again, that's not necessary in this solution, but wouldn't be incorrect. And then finally, we're going to print out our results. It says print them with the labels area and perimeter. Oops, and I forgot, I need to print it with 2 decimal places. That means I can't use the regular print command. I have to use format instead. So I'm going to say print the label area gets, And then I want to print the value of the area, which is a floating point value, and I want 2 decimal places. And then I'm going to calculate or print the label for the perimeter and then indicate the format for that second value. It's also a floating point number with 2 decimal places. And then finally, I'm going to list my variables that I'm printing here for the area and perimeter. So that'll wrap up my program. If you're in an exam situation, it's always a good idea to go back and read through your program. Make sure that you answered all of the requirements that were part of the problem description. If you're doing a practice problem, if you're preparing for an exam, but it's not an exam situation, you can also always copy and paste your code into IntelliJ. I have a blank window here, so I can paste it in. Once you have everything typed in, you can run your program. I'm going to use easy numbers so that I can do the math in my head for the area and perimeter using 10 as the length and 2 as the width. That means my area should be 20 and my perimeter should be 24. And that's what I got for my answer. And so that confirms that, at least for that test case, it's giving the correct answer. Since this program doesn't have any decisions in it, we can feel pretty confident that even when it works for one situation, it's going to work for any combination of situations. Certainly could run it with a few more test cases just to verify that. We're going to do another activity in just a minute. I need to get some stuff set up for that, so I'm going to pause this and then I'll be back in a second. Okay, today we were going to play a Kahoot, and there's not a good way to play Kahoot in a distributed asynchronous fashion. So I have Kahoot loaded up on my computer, and you can at least see what the questions were going to be, so you can use them for review and checking your own understanding. This is a review of the last few topics that we've covered class. So I'm going to play as me. We're going to go ahead and get started. So our first question is about the most appropriate data type to store a person's age in years. Think whether that would be an integer, character, double, or Boolean. I think for the number of years, it would be an integer. If you were thinking it could be a double, that would also be okay. And I would count that as correct on an exam. You can certainly be 3.5 years old. Let's look at the next question. What would be the most appropriate data type to store the exact price of a gallon of gasoline? Same choices, integer, character, double, or a Boolean. It would absolutely be a double for that one. Because it's a decimal value, we want to be able to capture the dollars and cents. So you'd have to have a decimal as the data type. Next question. What would be the most appropriate data type to store whether a student passed a course? So that's going to be like a yes, no, true, false kind of answer. What would be the best data type? A Boolean data type is designed to store true, false values. And so in a situation like that where the answer can only be true or false, a Boolean is a great choice. Here's an expression we're supposed to think about what would get stored in the variable result. You have to be careful with these. Sometimes they're tricky. So this one is 14 divided by 4. Those are both integers, so it's going to give us an integer answer. That would be 3, but then it's going to store it as the result. It's going to be 3.0 would get stored as the result for that one. And again, that's because 14 and 4 are both integers. So it's going to do the integer version of the division, the answer is really 3.5, but it's only going to store the whole number portion of that, which is 3, and then it'll use type coercion to turn that into a double for the storage. Let's look at this next one. This one's another calculation, same values, but now we have some typecasting on the top with the numerator. Would that change the answer? Now it's going to be 14.0 divided by 4. That's going to give us the decimal result, so we're going to get 3.5. Super. Similar question. This one's using modulus. So this one has 4 modulus 14. 14 goes into 4 0 times. And then the answer is going to be 4. Wait. I think this answer is thinking that the expression was written in the opposite order. If we had 14 mod 4, then the remainder would be 2. 2 would be correct. But 4 modulus 14, 14 goes into 4 0 times, and then the remainder is 4. It should have been 4 as the answer. Next, we're looking at an expression. This one is result gets 5 plus 3.0. Would Java automatically convert the 5 to a double before performing the addition? You guys think true or false? That would be true, because Java makes the data types of all the values in the expression the same. It's going to use type coercion to promote the 5 to a 5.0 before it adds the 3.0 to it, getting the answer 8.0. I think we've got one more question. Oh, maybe 2 more questions. Which of the following is a valid Java variable name? We've got second score, average grade, final grade, main. Only one of those is valid. Which one? That would be the final grade. Second score is not valid because it starts with a number. Average grade's not valid because it has the M dash in it. And main's not valid because that's a reserved word in Java. Last question. Which of the following will print a decimal value in a column of with 10 with 2 decimal places after it? It's definitely system.out.format. These all have a column of with 10. They all got the 0.2. Is it D for decimal or F for decimal? Oh, I was too slow. It's the F and the comma. That's the one that's correct. The F with the concatenation operator, the plus sign, that doesn't compile. And the D is for integers in Java. Awesome. So it was just a fun little review. Again, you can replay that and look at the example questions. You can also use those as inspiration with AI if you want it to generate some additional questions that you can use to practice for the exam. You can feed in example problems like those and ask it to generate additional examples for you to practice.